Welcome back. Today we're going to focus on different ways of writing an equation. So we're going to go over a situation with a word problem, a situation with a graph, and a situation with two coordinates. So here there's a verbal situation that we're going to use to figure out how to write the linear equation, because we're going to focus on linear equations today. All right, let's say that Greta makes clay mugs and bowls as gifts at the Crafty Pottery Studio. Every month she pays a membership fee of $15, okay? And so this is her membership fee, and an equipment fee of $3 an hour to use the potter's wheel. Now, you want to write an equation of the form y equals mx plus b that Greta can use to calculate her monthly cost. Okay, so every month she pays a membership fee, a constant fee of $15, and she pays a variable rate of, this is a rate, right? Remember, a rate is something per hour or something per something else. A rate is always given as 2 units that do not have the same measurement. So $3 for 1 hour, it's a measurement of dollars per hour, or a measurement of money over time. Okay, so there's your rate. So whenever we have these situations, we always want to look at the fixed cost and we want to look at the variable cost. The fixed cost for every month is $15 and the variable cost is $3. Okay, they all have the same patterns in them. So if you're able to identify them from the patterns, then you're pretty good at finding the equation. Okay, so let's just identify the input and output variable. So we have 2 units here. We have money, right? And we have hours. Okay, now remember, oftentimes the hours, as it is in this case, is independent and the money is dependent. So the money depends on the amount of hours, or the money in cost, what it costs to her, depends on the amount of hours she uses the studio for every month. Okay, the slope is always going to be the rate it's going to be the rate. Okay, because the rate, remember that rate of change has everything to do with rate of change. Well, the rate that we have is $3 per hour. So that's going to translate to us as 3 for the slope. Okay, the y-intercept is the fixed cost. So what is it that she's paying? It's called the fixed cost or the one-time fee. It's always presented in the problem as a one-time fee or a fixed cost. So that for us is the $15. Okay, so that's just going to translate to 15 because we're just going to keep it. Since the y is going to be interpreted as dollars, we can just write the amount in without the units. Okay, which would be dollars. So write the equation. Y is equal to, remember, m is the slope. Okay, so 3x plus 15. Okay, where x is equal to hours and y is equal to total cost in dollars. Okay, so let's just make sure this makes sense here. If I put, let's say that she spent 10 hours at the studio, you would calculate her cost as $3 an hour times 10 hours plus the $15 membership fee. So your total cost would be 30 plus 15, which would be 45. So your total cost in dollars would be $45, okay, for 10 hours. Okay, let's look at a graph right here and see if we can use the graph to figure out the equation. Now, what you want to remember is that sometimes the book draws, instead of drawing a line between the points, they draw a series of disconnected points because what they're trying to indicate here is that the line between the points don't make sense because the points on the line between the points that they've indicated doesn't make sense in terms of fees. So let's look at how this relates to the problem. A video club charges a one-time fee plus a rental fee. So there's your one-time fee. That's your B, that's your y-intercept, plus a rental fee for each DVD borrowed. There's your rate. Something for every something else, right? So a rental fee for every DVD. Okay, so that's going to be your slope. Use the graph to write an equation in slope-intercept form to represent the amount y of X DVD rentals. So let's look at what's going on for the graph. Okay, so we have this point right here, which is 0, 8. All right. Let's choose another point that's on the intersection of two grid lines. This one looks pretty good. This is 8 and 18. 8, 18. Okay. Let's make sense of these points. Okay. These are rentals, so it's 8 DVDs would be $18, and 0 DVDs would be $8. So just putting the units into the coordinates so I can sort of try to make sense of this all. Okay. So what this means is, and this is, remember, this is referring to this point right here. And this is referring to this point right here. Okay. Actually, you know what? I should put the first point in yellow because that's consistent with the way I was using it in the previous thing where the fixed cost was in yellow and the green was the slope. Okay. So this fixed cost is going to be the $8. That's going to be what you pay. When 0 DVDs are rented, it's going to be $8. And so after that, so actually let's go ahead and answer the question that we have first. Identify input and output units. Well, input units are going to be your X value. Okay, so that's going to go here. So the rentals go here. So amount spent right here, the money depends on the amount of rentals. That makes sense. Okay. So input is rentals and output is cost right here. Find the slope. Okay, so between these 2 points, notice I chose this point because it was on the intersection of the 2 grid lines. That's a good point because it means that the integers are, or the coordinates are integer values. So here I want to do rise over run. So it's 4. Be careful because it's not just counting the units here. It's not just going 1, 2, 3, 4, 5, because every space actually ends up being 2 units. So I want to be careful about finding rise. This is 8 to 18. That's a rise of 10. Okay, so rise is equal to 10. See, run. Now the run across, these are also, every dash here represents 2 units. So we want to go 1, 2, 3, or 2, 4, 6, 8. So our run is 8. And actually, in this case, it would have been okay for us to just count because the X and Y axes increment at the same rate. So it was okay for us to do that, but they both go up by 2 on the axes. So it's actually okay to, because this reduces to 5 over 4, which is the same as counting 1, 2, 3, 4, 5, and over 1, 2, 3, 4. Okay. That's because they would both share a common factor of 2 because they're increasing by 2 on both axes. So the slope is 5 over 4. So for every, let's see, for every 5 DVDs rented, it costs $4. That's another way to interpret the slope. Read the y-intercept from the graph. So our y-intercept is 8. So at 0 DVDs rentals, the membership fee is $8. So we're going to write the equation. Y is equal to, okay, our slope is 5/4 and x plus 8, okay, where x is equal to the DVD cost and y is equal to the, or DVDs rented, and y is equal to the total cost. Let's just make sure this makes sense here. So let's say that we rent 8 DVDs. 8 times 5 is 40 divided by 4 is 10, plus 8 is 18, and that would get us our 8, 18 coordinate right there. Okay? So just make sure when you're writing the equation to identify what x and y is, so that you can make sure you know what your units are. Okay, finally, this is our last example here. This is writing a linear equation given the coordinates. So let's say that you see this advertisement here, the monthly rates. The rent charge for a space in an office building is a linear relationship related to the size of the office rented. Write an equation in slope-intercept form for the rent at West Main Street office rentals. Okay, so here they say 600 square feet, right? That would be 600 squares that are a foot by a foot. Or if you look at the tiles inside of a school building, that would be 600 of the tiles inside of a school building because they're all a square foot. Okay, 600 square feet for $750 a month, or 900 square feet for $1,150. All right, identify our input and output. The rent in dollars depends on the square feet. Okay, find slope using the slope formula. Now, if we're given two coordinates, we can't use the rise over run like we've been using. So we're just going to have to use the slope formula, which is y2 minus y1 is x2 minus x1. Let me take a second and translate these into coordinates here. So we said that the independent was x and the dependent was the money right here. So the coordinates are going to be 600 square feet is $750, and 900 square feet is $1,150. Okay, so we'd have 1,150 minus 750, and let's see, 900 minus 600. Okay. Okay, and this is going to end up being 400 over 300, or 4 over 3. Okay, that gets interpreted as $4 for every 3 square feet, or 4/3 of a dollar per 1 square foot. Well, that would be like 4/3 of a dollar would be $1.33 essentially per square foot. Okay, but we only need the number here. So 4/3 is going to be sufficient for writing the equation. Okay, now in order to find the y-intercept, we can use a coordinate. So for instance, let's use 600 and 750. So 750 is the y, 600 is the x. So we can say 750 is equal to 600 times your slope right here plus your y-intercept. Okay, so 750 is equal to 600 times 4 is 2,400 divided by 3 plus b. 750 is equal to, that's 750, 800 plus b, and if you subtract 800 from both sides, you'd have b is equal to negative 50. Now this doesn't make a lot of sense when we try to interpret it in terms of the problem, because it would mean if you had 0 square feet, you're paying negative $50, or it's almost as if the business owes you $50, because if the positive amount is what you're paying, then a negative amount would be what they pay you. So it doesn't really make sense in terms of the problem. But if your main goal was to get the equation, then we could still write the equation. So we'd go y is equal to, so this is your m, right? Or this is your b rather. Your m is 4/3. 4/3 x minus 50. So if they ask you for that equation, that would be fine. But the y-intercept doesn't really make sense in the context of a real-world problem. Okay, you could also have used the table in this case in order to find the y-intercept, because this is going down at a rate of $300 a month, okay? Or 300 square feet drops by $350. So if you dropped another 300 square feet, it would be 300 is to, whoops, this is dropping by $400, sorry. That was, the answer was 350. So 750 minus 400 is 350. So 300 square feet would be 350. So 0 square feet would then get you the negative 50, because 350 minus 400 would get you that negative 50 is what we got when we used the coordinate here. So that's how we write the equation. The slope makes sense to us, which is like, you know, $1.33 a square foot, but the y-intercept doesn't necessarily make sense. And sometimes that happens with equations, but we still found the equation, which was the goal of the lesson for today. Okay, and that's the end of it. Thanks.